Okay, so today's notes are on section 5.3, solving polynomial functions. And our objective for today is to solve polynomial functions by factoring, and the language objective is to use the correct terminology to explain that process. So this is really building off of what we were doing last class. It's a lot of the same stuff, just taking it to the next step with some more complicated polynomials. So our first example asks, what are the real or imaginary solutions of the following polynomial? And we have the polynomial 3x to the fourth plus 12x squared equals 6x cubed. So the first thing we need to do to solve this is set the equation equal to 0. So to do that, we have to subtract our 6x cubed from both sides. And I'm going to write this in the middle so that my polynomial is in standard form. So I move the 6x cubed to the other side. Now I have a couple options. So if I want to just factor out the GCF, I can do that. But to make this easier on myself, since I see these are all divisible by 3 and the equation is equal to 0, I'm going to divide everything by 3 to simplify. So if I divide everything by 3 on both sides, I get x to the fourth minus 2x cubed plus 4x squared equals 0. So one thing you might be wondering is, well, there's an x squared in each term. Can I divide out the x squared? And one thing I want to note is that you cannot divide out variables, or x value in this case, because we need to solve for those possible x values. So you can't just divide out the x squared. You have to keep it in the equation so you can solve for those possible x values that you would try, if you had tried to divide it out, would have ended up canceling. So you can't get rid of variables while solving, is the key point. So now that I have my trinomial, now I can factor out a GCF to solve. So that's what I'm going to do next. And if you had kept, so if I notice all the terms have an x squared that I can factor out, so I'm going to factor that out. And if you had kept the 3 there, you could also factor out the 3. You will end up getting the same answer. I just think it's easier to work with if we divide out the 3. It's smaller numbers to work with. So now I have x squared times x squared minus 2x plus 4. And since there's 2 terms being multiplied, I can now use my zero product property. If I do want to check before I use my zero product property that this is not factorable, which it's not. There are no factors of positive 4 that add to negative 2. So since that's not factorable, I'm going to use my zero product property now. But you should always check to make sure that that is the most factored form that you can get the polynomial in. So now I have x squared equals 0, or x squared minus 2x plus 4 equals 0. And I'm going to solve out for x. So my last step is to solve both quadratics, or solve both equations for x. So here I have x squared, so all I'm going to do is square root both sides, and I get x is equal to 0, because plus or minus 0 would be 0 regardless. So one of my solutions will be x equals 0, and it would have a multiplicity of 2 if you're trying to remember that vocab from last class. So this one, as we said, is not factorable. So I need to solve the quadratic trinomial in another way. So the other ways we know to do that are completing the square or quadratic formula. That should be capital Q. So I know many of you prefer the quadratic formula, so I'll use that method to solve this out. So we do negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 4. So I plugged in my a, b, and c values, and then that's all over 2 times 1. Now I'm going to simplify, and I get x equals 2 plus or minus the square root of 4 minus negative 4 times 1 is negative 4 times 4 is negative 16, all over 2. So then I'm going to keep simplifying, and I get x equals 2 plus or minus the square root of negative 12 over 2. And now I have to simplify that radical, and I see that since there's a negative under the radical, I'm going to get an imaginary solution, or 2 imaginary solutions. No real solutions, 2 imaginary. So I have plus or minus And if you want to break this into pieces, to simplify this, I know 4 times 3. Well, first of all, I'm going to take out an I, because I know there's a negative under the radical. So I take out the I for the negative, and then to simplify 12, I know it's 4 times 3. So the square root of 4 is 2, so I'm going to take out a 2i, and I'm left with the 3 under the radical over 2. And my last step is to simplify this, so I get x. I have to divide both parts by the 2 in the denominator, so x equals 1 plus or minus I root 3. So my final solutions are x equals 0, x equals 1 plus I root 3, and x equals 1 minus I root 3. And those are my answers. Make sure you write down questions, comments, concerns on this. I'm going to flip the page for a quick check. So our quick check is going to be similar. I want us to solve 2x cubed minus 5x squared equals 3x. So pause this, go over it, or try it on your own. I'm going to go over it now. So my first step is to move the 3x to the other side. So I have 2x cubed minus 5x squared minus 3x equals 0. And there are not any terms I can, or common coefficients that I can divide out. So I'm going to factor out my GCF of x. I'm left with 2x squared minus 5x minus 3 equals 0. And this actually is factorable, so I'm going to take the quadratic trinomial to the side and factor this out for a second. So I'm finding factors of -6, so a times c, that add to -5, which are 1 and -6. So I'm going to use my middle term splitting method since my a isn't 1, and I get plus 1 my x minus 6x minus 3. I'm going to group my first two terms and my last two terms, put a little plus sign between them. The GCF here is going to be x, so I'm left with 2x plus 1. The GCF here is going to be -3, so I'm left with, again, 2x plus 1. So my factored form of this is 2x plus 1 times x minus 3. And so I'm going to put this back in the place of my quadratic trinomial that I previously had. So I have 2x plus 1 times x minus 3 equals 0. And now I'll use my zero product property. So in this case, we could solve by factoring. So that's what we did, but we need to do our last step with the zero product property. So my first solution will be x equals 0. The next one is 2x plus 1 equals 0. So I subtract 1 from both sides. And I get 2x equals -1, so x equals -1/2. That's my second solution. And then last but not least, I have x minus 3 equals 0, so x will equal 3. And those are the 3 solutions to that trinomial, or that cubic trinomial. All right, so the last thing I'm going to talk about very, very briefly is some of the factoring techniques we've learned. So polynomial factoring techniques. So just to sort of list some of the ones we've spent more time on, we've factoring out the GCF, so we've done that quite a bit. We factored quadratic trinomials with the middle term splitting method. We've done perfect square trinomials. And in case you forgot that, the general idea behind this is if we have a squared plus 2ab plus b squared, it would factor to a plus b squared, whereas if we had a squared minus 2ab plus b squared, it would factor to a minus b squared. So again, just to sort of review that concept, that's how you'd factor a perfect square trinomial. The other one we've talked about is the difference of two perfect squares, which again, as a quick refresher, it's if we have a squared minus b squared, it will factor to a plus b times a minus b, or switch the order. So the new one we're introducing today that I want you guys to be able to recognize, or actually, sorry, let me do one more before we do that. Factoring by grouping. This is part of our middle term splitting method, but you can use it without the middle grouping, sorry. You can use it without the middle term splitting method, so just because I'm not sure all of you know this terminology, we haven't talked about it explicitly. If we had something like this, it would factor like this, so you group them like we do with middle term splitting method, and you can get a times x plus y plus b times x plus y. And then that factors to a plus b times x plus y. So this is just the middle step of our middle term splitting method, but we call it factoring by grouping. So the new one I want to talk about for today is the sum or difference of cubes. So in this case, this would be if we had a cubed plus b cubed. This is the sum of two cubes. The way it will always factor, so sort of the same sort of rule as the difference of two perfect squares or perfect square trinomials, it will always factor to a plus b, so our original terms are the cube roots of our original terms, times the quadratic trinomial a squared minus ab, so again it switches signs when you go to the middle term, plus b squared. So again, you sort of take out one of each and then you put a minus ab in the middle. So our example for that, just so we can use some actual numbers, if we had 8x cubed plus 1, that would factor to the cube root of 8 is 2, the cube root of x cubed is x, cube root of 1 is 1, so you have plus 1, and then we are going to do 4x, because 2x squared is going to be 4x squared minus 2x, so because 2x times 1 is 2x, plus 1. So it would factor like that. We'll have some more practice with this in class. But the difference of cubes will similarly be a minus b, so this time if it's subtracting, the first term will be subtracted, and then you have the same thing, but now the middle term will be added, so it'd be a squared plus ab plus b squared. In our example for that, we'll use the same numbers, but it's if we had 8x cubed minus 1, that would factor to 2x minus 1 times 4x squared plus 2x plus 1. So that's all for today. Make sure you write down any questions, comments, concerns you have on this. We'll spend some more time with the sum or difference of cubes, but that's all for now. See you in class.